What's up? Welcome to the last installment of Algebra 2, I hope. Um, I'm going to dedicate this to who I call the COVID kids of 2020. I'm saying that because I wasn't originally going to even have this unit on data and statistics, but because of the whole COVID thing, COVID-19 making us go into pandemic lockdown mode, I guess, and Rhode Island doing the crazy great thing where they're doing the at-home long distance learning. I had to come up with some more lessons because I just looked at the calendar and said there's no way that this is going to be enough material versus in school where we would have had things like SATs take up more time. So I need to make sure I filled up this calendar with a little bit more. So this last unit, Unit 9, wasn't originally even intended. But here you go. This is the last thing I'm going to teach you online. I will be showing you in school, if we ever get back there, how to do some of this stuff using Excel and Google spreadsheets, which is basically the same thing. You can do a lot of cool stuff with that. So I'll be showing you that, as well as some of the techniques on the calculator itself. And then when you go into the stats class, the actual stats class, where you'll be learning so much more important, significant information, you'll have a good background information already with this stuff. So here's the last lesson, z-scores. This is for you COVID kids. The z-score measures how many standard deviations above or below the mean a data point is. It's pretty easy to do. You take your data point, you subtract the mean, and you divide by your standard deviation. Here it is in formula. Your z-score equals x, right? That's your data point minus your mean average divided by standard deviation. Generally speaking, right, a positive z-score means data point is above average. A negative z-score would be below average. Anything close to 0 is closest to the average, and then anything plus or minus 3 is considered unusual. Now, if you think back to the normal distribution curve that we saw, which I believe we might have to draw them here, we might not. I don't think we do. But if you remember, those worked with adding and subtracting a standard deviation to both sides. And there were only 3 on both sides, and anything that was past those was considered unusual. So it makes sense that we would be getting the same kind of thing. How far away? This is just basically giving us a different way of looking at that scale. And I'm going to say right now, before we get into the math, that to be honest with you, in my opinion, this is not the most exciting piece of information, because you could probably look at the data point and the mean itself and try to figure out how far away it is. Is it really close? Is it really far away? But this gives you a definite answer. So not the most useful, but I guess it could be somewhat. So anyways, we're going to look at some information that's already given to us, right? This one says Ashley scored a 91 on a recent quiz. The class average was an 88 with a standard deviation of 0.9. Find Ashley's z-score. So we want to figure out, was she like really far above average? Was she above average, close to it? We know she was above, but we want to know how close. So we're going to take her score. We'll subtract the average and then divide by the standard deviation. 91 minus 88 divided by 0.09. So just got all that right there on the calculator. And it says 33.3. Oh, I'm sorry. I did too many. I had too many zeros. 3.33. So Ashley's score was a 3.33, so she was more than 3 standard deviations above the average. So this must have been a very specific information quiz that these kids took, and Ashley happened to do much better than everybody else because she was above 3 standard deviations. She was probably the only one to score that high on this particular quiz. Everybody else probably scored exactly 88 or around there. So here you go. Here's one for you to try. It's a very similar formula. Pause the video and check it when you're ready to see your answer. All right, so let's see. Different class. One scored an 81. The average was an 85 with a standard deviation of 3. here we get negative 1.3. So he wasn't that far away. He was a little bit more than one standard deviation away, but he was still pretty close to the average. All right. So now we're going to look at some situations. These are as close to authentic as I could get using Google. Kind of bored being locked up in here. But I looked up for Division 1A high school football teams in the 2019 season, how many points they scored. Okay, I looked it up and I only went with the league numbers and added it all together. But for 2019, here are D1A scores. This is a 6, by the way, just so you're all clear. So we're going to be asked to find the average point scored, calculate the standard deviation, and there's a couple of questions down there they're going to ask us after. So let's start by doing these first few things. Find the average points scored. Actually, I'm not going to even write all that down. You guys know how to find that. It's the sum divided by total, which is 8. So we're just adding everything together. It doesn't tell us what's around to for this, so why don't we make life easier and we'll go to the nearest whole number. So it's 161.6. Let's do 162 for our average. So we just found X bar is a name for it. Okay, the mean average. We want to now calculate the standard deviation. I should have definitely left more room for this, but I'm going to have to take and subtract, square it to find the variance, add all that together. All right, so there's quite a bit of work. So again, I'm going to do it all out. You can pause this and then fast forward if you want to, whatever you want to do. It's up to you. 280, oops, minus 162 squared. By the way, I'm doing the subtraction and then squaring all in one step here, so you might not hear me say too much stuff right now. I'm just trying to get this stuff done. This is one of the problems about statistics, in my opinion. It's a lot of number crunching. So it's a lot of just kind of like being quiet for a minute. I'm not good at that. Let's see, I got one more to go. All right, now we're going to add all these together and divide by 8. So I got 4,765 divided by 8. So we just found the variance was 5995.6. Now we just got to take the square root. 5995.6 under the square root, and that would be 77.4. Okay, well, that seems to be our standard deviation. I wonder if I messed up somewhere. Let me just... You guys can fast forward over this stuff anyway, so I'm just going to make sure I didn't add anything wrong here. Okay, well, so it seems to be correct. So, Hendricken scored 280 the most, Cumberland 135, somewhere in the middle, and Cranston East only 31. So, let's see if any of these teams had unusual scores for the season. So if we take 280 and we subtract 162 and then divide it by 77.4, this is Bishop Hendricken's z-score here. 280 minus 162 divided by 77.4 is 1.52. Again, didn't say where to round to, so we'll say 1.5 for Bishop Hendricken's z-score. That is not unusual at all. 135 minus 162 over 77.4. This should be really close because they're kind of right in the middle. So they were a little bit below, obviously, but 3, 4, 9. So this was Cumberland. Had a z-score of negative 0.3, so they weren't really that far off. They were kind of close to zero, close to the average. And then finally, Cranston East only scored 31 points. And they had a negative 1.69 z-score. So they definitely scored very few points. I mean, you look at some of these other